Welcome to my advanced physics class online. You can join this class if you're a physics lover. It's time to build some mathematical foundations that will help us delve into physics better. Click on the notification bell, like, subscribe, and share. We start off with vectors. In physics, several quantities have both magnitudes and directions. Such quantities include forces, momenta, impulses, acceleration, displacement, just to mention a few. Those quantities can be illustrated in the two-dimensional plane. Now, in one dimension, left and right can be used to resolve any problem. But in two dimensions, the directions are infinite. Therefore, we need a quantity that can lump both the x and the y as one. This is an illustration. This is a two-dimensional space, mostly referred to as 2D. Now, if say a man walks a distance in this 2D plane on the first day, then he walks another distance on the second day. We ask you, where is he from home? He could be infinite points from home in this 2D plane. It could be here, it could be there, it could be here, it could be also there. So for that matter, the first day he walks a distance, we illustrate that with an arrow. I mean a line with an arrow on it. We call this a vector. We denote a vector using a letter from the alphabet and an arrow on top of it. We call this vector A. Of course, on the second day he walks another distance, we can call that vector B. Now, where is he from home? Is a point from the origin, a vector lumping both the A and the B. We can call that vector C. So then it turns out that vector C, being the overall vector, is vector A and plus vector B. Let's describe singular vectors into details. If we isolate vector A in the 2D plane, we can analyze vector A in so many ways. One, we could see that vector A has a component in the x direction, of course a component in the y direction. Now, the component in the x direction has a length, and this is the length. That length can be denoted as ax, the magnitude in the x direction. Then the component in the y direction will have a magnitude ay. This is just a denotation. So we ask the question, how can we make ax a vector? This is just a magnitude. If we want to transform it into a vector, then we need to introduce a quantity with a magnitude 1, but then with a direction. We call it a unit vector, x roof. Then same for y direction, we call it y roof. There are two denotations for that. It's either x roof or I, or y roof or j. So this vector in the horizontal direction is ax, x roof, then ay, y roof in the vertical direction. So vector A can be decomposed as ax in the x roof direction or I direction plus ay in the y roof direction. That is how to decompose a vector. This is also reflecting how we add vectors, the same way we did for C, being A plus B. Now, what is AX? Then what is AY? Given a vector A. We can deduce the value of AX knowing the angle the vector makes with the horizontal, theta. And for that matter, AX is going to be the magnitude of A, which is written without any arrow on top. Cosine that angle, that is this one. And AY is of course the magnitude A, the sine of the angle it makes with the horizontal. These are really important. So given an overall vector A, we can deduce the magnitudes in the respective axis, either X and then Y. So we have A, which could be written as, we have A cosine of theta, X roof, and then plus the same A sine of theta, the Y roof, which is a reflection of this one. In summary, we have A factorized out, we have cos theta in the X direction plus sine theta in the Y direction. Now, if AX X roof is a vector in the X direction, so AX X roof is a vector in the X direction, then what is X roof? X roof will be equal to AX divided by AX without a bar. We call this a unit vector. That's how we define a unit vector. It is a vector itself divided by its magnitude.